Photocell failure in mercury vapor lights can stem from several causes. Firstly, incorrect photocell type could be the issue. Ensure that the replacement photocell is compatible with the 1000-watt mercury vapor light. Different light fixtures require different photocell ratings. Secondly, overloading could be to blame. If the photocell is rated for 15.6 amps, while the light is drawing 13 amps, this may be causing the photocell to overheat and fail prematurely. Thirdly, voltage fluctuations can damage photocells. Voltage spikes or drops in the electrical system can damage photocells. It is advised to install a voltage regulator to protect the photocell from these fluctuations. Fourthly, aging and wear is a factor to consider. Photocells degrade over time. If the photocell has been in use for a prolonged period, it may simply need to be replaced. Fifthly, a defective light fixture might be the root cause. An electrical fault within the light fixture, such as a short circuit or loose connection, can disrupt the photocell's operation and cause it to fail. Sixth, improper mounting can cause issues. Ensure that the photocell is mounted securely and in a shaded location. Exposure to direct sunlight can damage the photocell. Seventh, a corrosive environment can be the cause. If the photocell is exposed to corrosive elements such as salt or moisture, it may degrade more quickly. And eighth, incorrect wiring could be the problem. Verify the wiring connections between the photocell and light fixture. Loose or incorrect connections can cause malfunctions. To solve the problem, consider these suggestions. Firstly, replace the existing photocell with a compatible photocell rated for the light's amperage. Secondly, install a voltage regulator to protect the photocell from voltage fluctuations. Thirdly, check the light fixture for any electrical faults and repair as necessary. Fourthly, inspect the wiring connections to ensure they are secure and correct. Fifthly, consider replacing the photocell if it is old or has been exposed to a corrosive environment. And sixthly, mount the photocell in a shaded location to avoid direct sunlight exposure. Let's delve deeper into each of these potential causes and solutions. When choosing a replacement photocell, it's crucial to verify its specifications against the requirements of the 1000-watt mercury vapor light. The voltage and amperage ratings should match or exceed the fixture's demands. Consult the light fixture's documentation or a qualified electrician to determine the appropriate photocell type. Overloading, even if seemingly within the photocell's rated capacity, can still lead to premature failure. A 15.6 amp rating represents the maximum sustained current the photocell can handle under ideal conditions. Factors like ambient temperature, internal resistance, and manufacturing tolerances can reduce its actual capacity. The 13 amp draw of the mercury vapor light might be pushing the photocell close to its limit, especially if the light has a high inrush current when it initially starts. An inrush current is a surge of current that happens at startup, which is much higher than the running current. Inrush current is the instantaneous high input current initially drawn by an electrical device when it is first turned on. The instantaneous peak can be many times larger than the steady-state full load current. Voltage fluctuations are a common occurrence in electrical systems, particularly during peak demand periods or when large appliances are switched on or off. These fluctuations can manifest as voltage spikes, which are sudden increases in voltage, or voltage drops, which are temporary decreases in voltage. Both types of fluctuations can damage sensitive electronic components like photocells. A voltage regulator stabilizes the voltage supply to the photocell, protecting it from these harmful fluctuations. There are different types of voltage regulators available, including surge protectors, line conditioners, and uninterruptible power supplies. Choose a regulator that is appropriate for the specific voltage and amperage requirements of the mercury vapor light and photocell. As photocells age, their internal components degrade, leading to a gradual decline in performance. The light-sensitive element, typically a cadmium sulfide or silicon-based resistor, becomes less responsive to light, causing the photocell to switch on later in the evening and off earlier in the morning. The internal circuitry may also become more susceptible to voltage fluctuations and temperature changes. If the photocell has been in use for several years, it's likely nearing the end of its lifespan and should be replaced. An electrical fault within the light fixture can create a variety of problems for the photocell. A short circuit, for example, can cause a surge of current that overwhelms the photocell and damages its internal components. A loose connection can create intermittent voltage drops, which can disrupt the photocell's operation and cause it to switch on and off erratically. To check for electrical faults, visually inspect the wiring and connections within the light fixture. Look for signs of damage such as frayed wires, loose terminals, or burned components. Use a multimeter to test the continuity of the wiring and the voltage at various points in the circuit. If you find any faults, repair them immediately or consult a qualified electrician. Improper mounting can also contribute to photocell failure. If the photocell is not securely mounted, it may be subjected to excessive vibration or mechanical stress, which can damage its internal components. Exposure to direct sunlight can also overheat the photocell, shortening its lifespan. Mount the photocell in a location that is shaded from direct sunlight and protected from the elements. Ensure that the photocell is securely fastened to the light fixture or mounting bracket. A corrosive environment, such as a coastal area with high salt content or an industrial area with high levels of pollution, can accelerate the degradation of photocells. The corrosive elements in the air can attack the photocell's internal components, causing them to corrode and fail prematurely. If the photocell is located in a corrosive environment, consider using a photocell that is specifically designed for harsh conditions. These photocells typically have a protective coating that resists corrosion. It's also important to regularly clean the photocell to remove any accumulated dirt or debris. Incorrect wiring can cause a variety of problems for the photocell. If the wiring connections are loose or incorrect, the photocell may not receive the proper voltage or current, which can cause it to malfunction. Incorrect wiring can also create a short circuit or ground fault, which can damage the photocell and other components in the circuit. To verify the wiring connections, consult the wiring diagram for the light fixture and photocell. Ensure that all connections are tight and secure. Use a multimeter to test the continuity of the wiring and the voltage at various points in the circuit. If you find any incorrect wiring, correct it immediately or consult a qualified electrician. When replacing the photocell, choose a compatible model that is specifically designed for use with mercury vapor lights. Check the voltage and amperage ratings to ensure they match the requirements of the light fixture. Consider using a photocell with a higher amperage rating than the existing one to provide a safety margin and prevent overloading. A voltage regulator can protect the photocell from voltage spikes and drops, extending its lifespan. Choose a regulator that is appropriate for the specific voltage and amperage requirements of the mercury vapor light and photocell. Install the regulator according to the manufacturer's instructions. To check the light fixture for electrical faults, visually inspect the wiring and connections. Look for signs of damage such as frayed wires, loose terminals, or burned components. Use a multimeter to test the continuity of the wiring and the voltage at various points in the circuit. If you find any faults, repair them immediately or consult a qualified electrician. Inspect the wiring connections to ensure they are secure and correct. Loose or incorrect connections can cause malfunctions. Consult the wiring diagram for the light fixture and photocell to verify the connections. If the photocell is old or has been exposed to a corrosive environment, consider replacing it with a new one. Choose a photocell that is specifically designed for harsh conditions if the light fixture is located in a corrosive environment. Mount the photocell in a shaded location to avoid direct sunlight exposure. Direct sunlight can overheat the photocell and shorten its lifespan. If possible, mount the photocell on the north side of the light fixture or in a location that is shielded from direct sunlight. Mercury vapor lights typically require a specific type of photocell that is compatible with their operating characteristics. Using an incompatible photocell can lead to premature failure or erratic operation. Consult the light fixture's documentation or a qualified electrician to determine the appropriate photocell type. Consider the photocell's operating voltage, which should match the voltage of the electrical system. Common voltages for photocells include 120 volts, 208 volts, 240 volts, and 277 volts. If the photocell's operating voltage does not match the system voltage, it will not function properly and may be damaged. The load rating of the photocell, measured in amps or watts, should be sufficient to handle the current draw of the mercury vapor light. The photocell's load rating should be higher than the light's current draw to provide a safety margin and prevent overloading. The turn on and turn off delay times of the photocell determine how quickly it responds to changes in ambient light. Some photocells have adjustable delay times, allowing you to fine-tune their sensitivity. The operating temperature range of the photocell should be suitable for the environment in which it will be used. Some photocells are designed to operate in extreme temperatures, while others are more sensitive to temperature changes. Check the photocell specifications to ensure it can withstand the expected temperature range. In some cases, the mercury vapor light itself may be contributing to the photocell's failure. If the light is producing excessive heat, it can damage the photocell over time. Similarly, if the light is emitting electromagnetic interference, it can disrupt the photocell's operation. Consider replacing the mercury vapor light with a more energy-efficient and reliable lighting technology, such as light-emitting diode, or LED. Light-emitting diode lights produce less heat and electromagnetic interference than mercury vapor lights, which can help extend the lifespan of the photocell. When installing a new photocell, be sure to follow the manufacturer's instructions carefully. Improper installation can damage the photocell or cause it to malfunction. Ensure that the photocell is properly wired and securely mounted. Protect the photocell from moisture and other environmental factors. Regularly inspect the photocell for signs of damage or wear. If you notice any problems, replace the photocell immediately. By taking these steps, you can help prevent photocell failures and ensure that your mercury vapor light operates reliably. Consider consulting with a qualified electrician for assistance with troubleshooting and repairing the lighting system. An electrician can help identify the root cause of the photocell failures and recommend the best course of action. They can also ensure that the lighting system is properly installed and maintained. Mercury vapor lights are an older lighting technology that is gradually being replaced by more efficient and environmentally friendly alternatives. While they offer certain advantages, such as high light output and long lifespan, they also have some drawbacks, including high energy consumption and the presence of mercury, a toxic substance. Consider upgrading to more modern lighting technology, such as light-emitting diode, or LED, to save energy and reduce your environmental impact. Light-emitting diode lights are more energy-efficient, longer-lasting, and mercury-free. They also offer a wider range of color temperatures and dimming options. When working with electrical equipment, it's essential to take proper safety precautions to prevent electric shock and other hazards. Always disconnect the power supply before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electrical equipment, consult a qualified electrician. Photocell technology has evolved over the years, with new models offering improved performance, reliability, and energy efficiency. Consider upgrading to a more advanced photocell model to take advantage of these benefits. Some newer photocells feature built-in surge protection, which can help protect them from voltage spikes. Others have adjustable sensitivity settings, allowing you to customize their response to ambient light. Some photocells are also designed to be compatible with a wider range of lighting technologies, including light-emitting diode lights. When selecting a photocell, consider its warranty period. A longer warranty period indicates that the manufacturer has confidence in the product's reliability. Be sure to read the warranty terms and conditions carefully to understand what is covered. In some cases, the photocell may be failing due to a problem with the wiring in the electrical circuit. Check the wiring for any loose connections, damaged insulation, or other signs of wear. Repair any damaged wiring or replace it as needed. If you're not comfortable working with electrical wiring, consult a qualified electrician. Photocell orientation can impact performance. Ensure that the photocell sensor is facing the appropriate direction to accurately detect ambient light. The photocell sensor should typically be facing upwards or outwards away from the light fixture itself. Adjust the photocell's position as needed to optimize its performance. Light trespass occurs when artificial light spills over onto neighboring properties, causing annoyance or disruption. To minimize light trespass, use shielded light fixtures that direct light downwards and prevent it from shining outwards. Adjust the photocell sensitivity settings to ensure that the light only turns on when it's needed. Consider using a timer to automatically turn off the light at a specific time each night. Consider local ordinances and regulations regarding outdoor lighting. Some municipalities have specific requirements for light levels, shielding, and operating hours. Ensure that your lighting system complies with all applicable regulations. A poorly designed or installed lighting system can create safety hazards. Ensure that the lighting system provides adequate illumination for walkways, driveways, and other areas where people may be walking or driving. Avoid glare, which can impair visibility and create discomfort. Use appropriate lighting levels for different tasks and activities. Consider the color temperature of the light. Warm light 2700-3000 Kelvin is generally more relaxing and inviting, while cool light 4000-5000 Kelvin is more stimulating and provides better visibility. Choose a color temperature that is appropriate for the specific application. Regularly clean the photocell lens to remove any dirt or debris that may be blocking the light sensor. Use a soft, damp cloth to clean the lens. Avoid using harsh chemicals or abrasive cleaners, which can damage the lens. Check the photocell's mounting bracket for any signs of rust or corrosion. If necessary, replace the mounting bracket to ensure that the photocell is securely mounted. Consider using a photocell with a built-in test function. This function allows you to manually test the photocell to ensure that it is working properly. The test function can be useful for troubleshooting problems or for verifying that the photocell is operating correctly. If you have multiple outdoor lights controlled by a single photocell, consider using a multi-tap transformer to provide power to the lights. A multi-tap transformer allows you to adjust the voltage to each light individually, ensuring that they all receive the correct voltage. If the Mercury vapor light is located in a remote area, consider using a solar-powered lighting system. Solar-powered lighting systems are self-sufficient and do not require a connection to the electrical grid. They are also environmentally friendly. However, solar-powered lighting systems may not be suitable for all applications, as they require sufficient sunlight to operate. Consider the potential for vandalism or theft when choosing a photocell and light fixture. Select a photocell and light fixture that are durable and resistant to vandalism. Install the light fixture in a location that is difficult to access. Consider using security cameras to deter vandalism and theft. Keep records of all maintenance and repairs performed on the lighting system. This information can be useful for troubleshooting problems and for tracking the lifespan of the photocell and other components. By following these tips, you can help ensure that your Mercury vapor light operates reliably and efficiently for many years.